Throughout the long shutdown too, more than 150 people from 15 teams, coming from 4 different CERN departments, external firms and 5 collaborating institutes from all around the world, worked continuously in the LHC tunnel on the Diodes Insulation and superconducting magnets consolidation project, also known as the DISMAC project. Their task is to improve the electrical insulation of the diodes, the parallel circuits allowing the current to be diverted in the event of a quench, of the accelerator's 1,232 dipole magnets, and to carry out a series of other activities. The project was prepared for almost 2 years in order for its tools and interventions procedures to be developed and optimized. The first interventions in the tunnel took place in March of 2019 and ended in October 2020. This maintenance process is rather complex, consisting of over 50 consecutive steps which need to be repeated 1,232 times, once for each of the LHC dipoles. An IT tool, the Web Interface Shutdown for the LS2, was developed exclusively in order to coordinate and control this complex workflow. This tool also acts as an access point to the rest of the IT tools that are used in the DISMAC project, but we will see more about them in a minute. Let's have a look at the main steps of the DISMAC project first. Everything starts with the opening of the interconnections. First of all, the radiation levels are checked to ensure the safety of the members of the DISMAC teams. These checks are repeated multiple times during the intervention. Then the outer shells are displaced, the thermal shields are removed, and all adjacent equipment is protected to prevent any damages during the intervention. In the long shutdown too, 1,360 interconnections in total will have been opened. The next step concerns the mechanical cutting of the diode containers. 2,664 diode container covers, 2 covers per interconnection, need to be cut in order to give access to the diode. The cleaning of the diode container follows. Metallic and other debris which are present in the diode containers are removed using specially adapted vacuum cleaners, which are fitted with an endoscope The main part of the consolidation of the dipole insulation system can now start. It includes the improvement of the insulation of the connection between the diodes and the bus bars, known as the half-moon connection, and the installation of an insulating insert to improve the insulation of the bus bars themselves near the half-moon connection. Throughout the consolidation, more than 10,000 quality controls will have been carried out. The various quality control teams make inspections on the welds and the lines of each magnet and check the quality of the diode consolidation to ensure the quality of the intervention procedures. Typically, every intervention step is interleaved with a quality control step to make sure that every task is performed as expected. If a nonconformity is identified during one of the quality controls, it is fixed in due time, while in order to resolve some older nonconformities, 19 dipole magnets have had to be completely replaced as part of the project. In all these steps, 2 IT tools are used. The first one is EAM Lite, an in-house developed, simplified interface of the organization's enterprise asset management system. It's used to perform quality controls throughout checklists and to facilitate the documentation of the various steps in EDMS. EDMS, the organization's engineering data management service, is used to permanently record data related to the intervention for the next generations of CERN's engineers. In addition to the quality controls of the consolidation, electrical quality assurance tests are conducted throughout the intervention in order to verify the continuity, configuration and integrity of the insulation of the LHC electrical circuits, as they must be qualified before powering can start again. After the consolidation, the diode covers are rewelded. The welded interconnections undergo local leak tests to ensure that there aren't any helium leaks caused by the intervention of the DISMAC project. Once all the activities are completed, the interconnections are ready to be reclosed. The cryo-instrumentation protection is removed, the outer shells, the thermal shields and all the equipment that was removed is reinstalled, and the BLM and QPS instrumentation cables are reconnected. This project is mandatory to safely increase the LHC energy and produce collisions at more than 13 teraelectrovolts, revealing unknown territories, and this would not have been possible without the dedication, professionalism and commitment of all the team members. We are already looking forward to the next installment as Run 3 gets underway in 2021.